Listen. An important theorem. Thales theorem. Thales theorem. The another name for this theorem is basic proportionality theorem. Please write this also. It is also called as basic proportionality theorem. Basic proportionality theorem. Now listen carefully. First, whenever you are going to prove any theorem, not only basic this Thales theorem, we have a converse of basic proportionality theorem. That is also there. And one more theorem is there, angle bisector theorem. I don't know whether it is there in your textbook. Okay, so this theorem is very important. First, if you want to prove the theorem, you have to write the statement first. All of you first start with, you have to write the title, then below this, what you have to write first, you have to write the statement. What the theorem says. Okay, that is called a statement. So please put a title, okay, statement, and under the statement, you have to write the definition of this theorem. So I'll write, okay, the definition we have to write it as it is. So it is given in your textbook. I'm going to use the same or the statement from your textbook. If a line is drawn, listen, please write the statement. If a line is drawn, please write fast. Parallel to, if a line is drawn, parallel to one side, line is drawn parallel to one side of a triangle, to intersect the of a triangle, to intersect the other two sides, to intersect the other two sides in distinct points. It is given in your bookmark. It is in page number 124. In distinct points. Comma, the other two sides are divided in the same ratio. Then the other two sides are divided in the same ratio. Then the other two sides are divided in the same ratio. Okay, this is the statement of the theorem. Okay, in this way you can write the statement. In this way you can write the statement R. Okay, R. I'm going to write the same statement in a simple way.
Yes, sir.
Okay, R, OR. In this way also you can write the statement, because it is given in first. I have written whatever I've written here is given in your textbook in page number 124. Now I'm going to write the same statement in a different way, which we used to write in our Tamil Nadu syllabus. Okay, so that I will write. But any method you can write. Okay, it is not a problem. The meaning is same. The meaning should be same. All of right. In another way, what we can write is a straight line. Whichever is easy for you, you can choose. Okay, a straight line. First write the statement, then I will explain the meaning of the statement. A straight line drawn parallel to a side. Parallel to a side. A side means a single side. Parallel to a side of a triangle. Intersecting the other two sides of a triangle, intersecting the other two sides. intersecting the other two sides. Other two sides, comma, divides the sides in the same ratio. That's it. Divides the sides in the same ratio. In the same ratio. Okay. While teaching this sum, okay, this theorem, I will teach you a lot of basic things. Okay, that is very, very important for a math student. Okay. So it will take some time, but after completing this theorem, you will remember this forever. Okay, whatever you are learning in this particular simple, this one theorem, lot of basics I will teach you. You will remember this forever. Okay, in that way I'll teach. Now listen. So in this two, okay, what to say, way of writing the statement, you can choose anything, whichever easy you can take. But both are same meaning, exactly same meaning. Okay, both are exactly the same meaning. Now, so I'm going to use some other color to teach you some concept. I'm going to make you understand what is the meaning of this theorem. First, I will explain you. Okay, now whatever I'm writing in the screen, no need to write. See here, only the black color, okay, I'm using, right? That alone you have to write. Have you all completed up to this, ma? The same
Yes,
ratio? Everyone?
Yes, sir.
If anybody needs time, please ask. Sorry? Completed.
Completed, sir.
Okay, now listen carefully, ma. It is very, very important. Listen. Just listen carefully. So this is a small jar. Just assume this is a small jar and this is a big one. So in this jar, a student is making a juice, okay, making juice with the help of water and essence. Okay, that is some fruit juice sodas. What is it? The crush. You'll have, right? We have to mix it with water to make a juice. So that what he is doing is that essence he is taking 1 liter. He is taking the essence, or else 2 liters. Okay, 2 liters he is pouring essence, and 6 liters. 6 liters he is pouring water. 6 liters of water with 2 liters of that juice essence. Are you able to understand this one? Now, what is the ratio of essence is to water? How will you write the ratio of essence is to water in this particular mixing? Is it 2:6?
Yes, sir.
Yes or no? Yes, 2:6. So we can write ratio in this form 2:6, or we can write it as 2/6. Ratio can be expressed in the form of division also. Ratio can be expressed in the form of division also. Now listen, this is first student, and the second student, he is taking a very big jar, and what he is doing is he is taking 3 liters of essence and 9 liters of water. 9 liters of water. Now, what is the ratio of this mixing?
3:9.
3:9. 3:9. Listen carefully. 3:9. So we can express this 3:9 in the form of division, because ratio can be expressed in the form of division. You all know that, right? So 3:9 can be expressed as 3/9. 1 minute, it is loading. Please wait. It's not responding. Wait a minute. Okay, it is 3:2. Again, it is not. Please wait, ma. Okay, it is 3:9. Now, please see here. Okay, the juice made by the student 1 and the second student, the first student and the second student have the same. Okay, it is having same taste. Okay, both are having the same taste, which means the mixing ratio, listen carefully, the mixing ratio 2:6 and 3:9 are in proportion. Are you able to understand?
Yes, sir.
That is why Okay, the taste of the juice made by first student and the taste of the juice made by second student are same. Okay, the same, because the ratio of their mixing is okay, both the ratios are in proportion. Both the ratios are in proportions means they are equal. So the definition for proportion is, if two ratios are equal, listen carefully, if two ratios are equal, then we'll call it as they are in proportion. Are you able to understand this concept?
Yes.
Yes. So similarly, listen, now you understood the word proportion. That is why I have taken this example. The meaning of this mixing is 2:6. The meaning of 2:6 is, it is 2/6. 2/6 can be simplified. So 2 ones are 2 and 2 threes are 6. It is 1/3. It is 1/3. The meaning is, for for example, for 1 part of essence, we have to add 3 parts of water. That is the meaning of this 2 liters of essence and 6 liters of water. Similarly, for 3 liters of essence, he is mixing 9 liters of water. So that is 3/9. A ratio can be expressed in the form of division. So 3/9 means 3 ones are 3 and 3 threes are 9. It is also 1/3. It is also 1/3, right? So 1/3 means, again, for 1 part of essence, he is mixing 3 parts of water. Therefore, 1/3 here also 1/3, which means 2/2:6 is equal to 3:9. Are you able to understand? These two ratios are equal. 2:6 is equal to 3:9. Hence, they are in proportion. Both the students are, okay, making the juice in proportion. Okay, they are proportionate. Okay, that is why the taste is same. Now listen carefully. Now you know the meaning of the word proportion. Proportion means when two ratios are equal, we call it as they are in proportion. Are you able to understand this concept, ma?
Yes, sir. Yes, sir.
Okay, now listen carefully. Again, I will explain the definition, that is the statement of this theorem. Okay, 1 minute.
Excuse me, sir.
Yes, ma. Yes.
Sir, 2.5 and 5, they are in proportion. 2.5 and 5.
2.5 and 5, you are asking whether they are in proportion or not. Yes, sir.
Yes, sir.
Listen, ma, it is a ratio actually. 2.5:5. You are telling one for this same thing. 2:6 and 3:9, right?
Yes, sir.
Oh no, for that 2.5:5 is not in proportion with this one, because 2.5:5 is in the ratio 1:2. That is called as 1:2. So 1:2 and 1:3 are different, right? They are not same. Both the ratios are different.
Yes, sir.
So 2.5:5 is not in proportion with this 1:3. That is 2:6 or 3:9. They are different. 1 minute, I'm not able to scroll up. Okay, I'll write here. Now, one more example. See here. Now, I'll take the same example. In this, this theorem says that you can draw any triangle you want. You can draw any triangle you want. A triangle has 3 sides. A triangle has 3 sides. Now, what we are going to do is, I'm going to draw a line. Listen carefully. I'm going to draw a line. Okay, it came here. Okay, no problem. I'll draw it here. Listen. So I'm drawing a line. Okay, these are all explanation. No need to write. Just observe. If you want, you can write it in somewhere else. Okay. First, we have written the statement. Now I'm going to explain the statement. What the statement is telling is, in a triangle, okay, it has 3 sides. You can consider any one side. Now, what I'm going to do is, I'm going to draw a line. Okay, this is the line. I'm going to draw a line, and that line is parallel to one side. That line is parallel to a side. A side means that any one of the side. We are drawing a line parallel to one side of a triangle. A triangle has 3 sides. This is one side, second side, and this is third side. Now I am drawing a line which is parallel to this one particular side. See here, you know what is called as parallel line, right? You know that, right? Or not?
Yes, sir.
Yes. So this line is parallel to this side. Now listen carefully. I'm going to mark it as A. Listen carefully, ma. I'm going to mark this vertex as A, and this vertex as B, and this vertex as C. Okay, I'm marking vertex A, B, C. Now I have drawn this line which is parallel to which side, ma? Parallel to which side of the triangle?
BC.
BC. So I'm drawing a line parallel to the side BC. Now this parallel line is intersecting the other 2 sides. That is, it is intersecting the side AB as well as it is intersecting the side AC. Yes or no?
Yes, sir.
So that point I'm going to take. Listen, this parallel line intersecting AB at D. That point I'm going to take it as this. This is called as point of intersection. This is called as point of intersection of the parallel line with AB, side AB. And this is called as this is the point of intersection of the parallel line with the side AC. So I'm going to consider this point as E. I'm going to consider this point as E. So now, just below the statement, listen carefully, ma. Just below the statement, in exam you can write any one of the statement. I have written the statement in two ways. Both have the same meaning. So just below the statement in exam, what you have to write is you have to draw this diagram. Please, all of you draw the diagram. In book, okay, in book they have used a different method. I'm going to teach the same thing in a different way. It is very easy. And again, if you want me to teach in the same method which is given in your textbook, also I am ready to teach. First, I'm going to teach in a different way. So this is a very simple method. Now, for that, you have to draw this diagram below the statement. All of you draw this diagram.
Done, sir.
Done.
Yes, sir.
Listen now. Okay, listen carefully. This is important now. That's the point. Okay, here is. Listen. Now we have drawn this diagram below the statement, right? Now see here. In this diagram, this parallel line intersects the sides AB and AC at two distinct points. Distinct means different points. Two different points, that is D and E. Okay, two different points, that is D and E. Okay, now, and this line is parallel to the one of the side, that is BC. Okay, these are all things you know. Now listen carefully, ma. Now this AB is called as line or line segment, which is perfect word to describe this AB, side AB. What is AB? What is AB? Is it a line or line segment?
Line segment.
Very good. Listen, this is called as line because it has arrow at the two end, right? Arrow means a line has no definite length. Actually, it is infinite, right? It keeps on going.
Yes,
that is why we are using this arrowhead. But this AB, the side AB is called as line segment. Usually we'll say line AB, line BC, but actual the word is line segment because it is having a definite length from A to B. Now, this line segment is divided by this parallel line into two line segments. What are they? AD and
DB.
AD and DB. Very good. Listen carefully. This line segment is divided into two parts. That is AD is one part and DB is another part. Likewise, this same line, dividing the other side, that is AC, into two parts. What are they? AE and EC. Yes. AE and EC. So what this theorem says is, if a line is drawn parallel to one side of the triangle, listen carefully, if a line is drawn parallel to one side of a triangle, it intersects the other two sides at distinct points. It intersects the other two sides at distinct points, that is D and E, comma, the other two sides are divided in the same ratio. What the theorem says, the other two sides are divided in the same ratio, which means, same ratio means, listen, this AD by DB, this is one ratio. Listen, AD by DB, because I have already told you, AD is to DB or AD is to DB can be, no need to write this, please observe. AD is to DB can be expressed as, ratio can be expressed in the form of division, that is AD by DB. AD by DB, this ratio is equal to, and this side, this line is dividing this AC into two segments, that is two segments, that is AE and EC, which is equal to AE by EC. Which is equal to AE by EC. Sorry, this is EC. AE by EC. So these two ratios are equal. These two ratios are equal. That is what we have to prove. Are you able to understand the statement now?
Yes, sir.
That's it. If you can take any triangle, you want. If any triangle, we are drawing a line that intersects one of the side of the triangle means, and that line intersects the other two sides at distinct points means, then that line will divide the remaining two sides, okay, proportionally in the same ratio. In the same ratio means they are in proportion. Okay, these two ratios are equal means it divides the two sides in a proportion. That is why it is called as basic proportionality theorem. Because two ratios are equal means we call it as proportion. So what you have to do right now is, listen, just below the diagram, listen, ma. Just below the diagram, what you have to do is, you have to write to prove. Please write to prove. To prove. Not able to write, ma. Please wait. Okay, listen, ma. So just below the diagram, please write this, ma. You have to write a topic like to prove. Please write to prove, and just below to prove, you have to write this: AD by DB is equal to AE by EC. Please write up to this. This is what we have to prove. Okay, that is the meaning of the theorem. A line is drawn parallel to one side of a triangle. Then the line divides the other two sides in the same ratio. That is AD by DB is equal to AE by EC. That is what we have to prove. Are you able to understand up to this step, ma?
Yes, sir.
Now,
Yes, sir.
now only we have to write proof. Now we are going to proof. We are going to do the proof. So please all of you write the topic proof. So first what you have to do, you have to write statement. First you have to write the title, that is basic proportionality theorem or Thales theorem. Just below the title you have to write statement of the theorem, and below the statement you have to draw the triangle, and next to the triangle, okay, the drawing, we have to write to prove. What do you have to prove? That is AD by DB is equal to AE by EC. Okay, now one thing you can do, ma. See here, just near to this diagram, please mention DE is parallel to which side?
BC.
BC.
BC, very good. D is parallel to BC. This is the symbol to represent parallel, right? Two vertical lines. D is parallel to BC. So please mention this now. Okay, that is enough. Okay, now we'll do the proof now. So it is very interesting proof. So first thing, you all studied about parallel lines cut by a transversal. Do you remember that? Yes, sir.
Yes,
Yes.
So I'm
Yes,
going to
sir.
use that property because it is in the 9th standard syllabus, right? Listen carefully. So consider this as this DE is parallel to BC. Yes or no? DE is parallel to BC, and this AB is a transversal. Are you able to understand this? This AB is a transversal. So I will explain that. Okay, I will just give a quick revision of that. So whatever I'm going to write now, please no need to write. Okay, just for your understanding. See, these are two parallel lines. When it is cut by a transversal, transversal means a line which cuts two or more lines. So this is a transversal. This line is a transversal, and these two lines are parallel lines. Two lines are parallel lines. It is a transversal. Now this angle will be equal to this one. What is the reason? They are called as corresponding angles. Do you remember that one? This corresponding angles are equal.
Yes, sir.
Yes. So these angles are equal. Suppose we are considering this as 1 and this is 2, means this is 1 is equal to. Usually you will not consider it as 1 and 2. This 1, this is 2, this is 3, 4, 5, 6, 7, 8. Okay, I'll write like this. This is 5, this is 6. Sorry, ma'am. Okay, 1, 2, this is 3, this is 4, this is 5, this is 6, 7, this is 8. Now see here, 1 and 2 are called as corresponding angles. Corresponding angles are equal when two parallel lines cut by a transversal. So according to that, so similarly, so in this triangle, listen here, in this triangle, we have drawn a line that is passing through DE that is parallel to the side BC. Now tell me, if DE is parallel to BC and AB is the transversal, now please answer me whether these two angles are equal or not.
Yes, sir. They are
These two angles
equal.
are equal. So please mark an angle, okay, here and put it 1 over here. Here also you have to mention 1 because both the angles are equal. These two angles are equal. That is why we are writing it as 1. Okay, I'm mentioning it as angle 1. Here also angle 1. Both are equal because corresponding angles are equal when two parallel lines are cut by a transversal. Now, similarly, now see here again, this D is parallel to BC, and consider this AC as a transversal. Now, these two angles are parallel or not? So these two angles are corresponding angles or not?
Yes, sir. They are
So
corresponding.
therefore, I'm going to mark it over here. This is angle 2 and this is also angle 2 because both the angles are equal since DE is parallel to BC and AC is a transversal. So these two angles are corresponding angles. That is why they are equal. You can mark it in the diagram itself. Then we can write it. Okay, write the thing in the proof, under the proof. First, you have to mark it over here. Now, this angle at A, vertex A, angle at A, I'm going to mark it as, I'm going to mark this angle as angle 3. Please mark it as angle 3. This angle A, please mark it as angle 3. Angle at vertex A is 3. Completed, Amma? Completed the drawing?
Yes, sir.
Okay, good. Now listen here. Listen, Ma. With the help of this diagram only, I'm going to do the proof. Again, I'm repeating. With the help of this diagram only, I'm going to do the proof. So see here now, just below the proof, you have to start writing whatever I'm writing in the screen. Now, first step is, so I'm going to prove this step by step. I'm going to prove this as step by step. So step one. So step one is angle. First, right? I will explain. Okay, then I'll explain using the diagram. Angle ABC is equal to angle ADE because both are equal to angle 1. Both are mentioned as angle 1. In bracket, all of you write in bracket, corresponding angles are equal. In bracket, what you have to mention, Ma?
Corresponding
angles are
equal.
Equal. Corresponding angles are equal when two parallel lines are cut by a transversal. You can simply write corresponding angles are equal. No need to mention two parallel lines cut by a transversal. Okay, that is understood. Or else you can write comma, put a comma and write D is parallel to BC. D is parallel to BC and put a bracket. See here, I will tell you where it is, which is angle ABC and which is angle ADE. In diagram already we have mentioned that. Listen, this is ADE. This is angle ADE and this is angle ABC. So this one is ABC angle, that is mentioned as 1, and this is angle ADE. So these two are equal. Am I right or wrong?
Yes, sir.
Yes.
Sorry, Ma, you want me to explain it again?
No, sir.
Okay. Now, similarly, so step 1 you have understood, right? Step 1 you have understood. So now listen carefully, Ma. It is very, very important. Now, next step is step 2. Step 2. Okay, now write angle ACB. ACB is equal to angle AED. Okay, angle AED. That is mentioned as which is equal to angle 2. Again, here also in bracket you have to mention what is the property you have to mention here is they are corresponding angles. Corresponding angles are equal. Corresponding angles are equal when two parallel lines cut by a transversal. Here, please mention corresponding angles are equal, comma, because DE is parallel to BC. D is parallel to BC. I will explain now. Please write this, then I'll explain. All of you write the step 2. Okay, completed Amma, step 2. Now listen, I will explain what is step 2 because already we have mentioned in the diagram. That is ACB. This is angle ACB. This angle is mentioned as angle 2. That is equal to AED. This is angle AED. That is also mentioned as angle 2 because these two angles are equal. They are corresponding angles because DE is parallel to BC and AC is the transversal. Are you able to understand, Ma?
Yes, sir.
Okay, that's it. Now, third step, step number 3. So with the help of diagram only, I am explaining step 1 and step 2. Now, step 3. Step 3. Step 3 is angle DAE is equal to, angle, sorry, listen carefully. Angle DAE is equal to angle BAC. Both are equal to angle 3. Both are equal to angle 3 because both in bracket you can mention both triangles. Both triangles. What are the triangles means? One triangle is you can mention both the triangles. Again, you can put a bracket, you can mention triangle This is the symbol to represent triangle. Triangle ABC and triangle ABC and triangle ADE. Both triangles have a common angle. In bracket, you have to mention both triangles have a common angle. All of you write up to this, then I'll explain using the diagram. Please write now. This is step 3. Completed, Amma?
Yes,
No, sir.
Okay.
No,
Now see
sir.
here. So I'm this single triangle. 1 minute, it's loading. Wait a minute. Okay, listen, ma. See here. See the diagram. You can see your diagram. See in this diagram, this is triangle ADE, small triangle ADE. This is small triangle ADE. In this triangle also, angle A is equal to 3. That is, this is angle DAE. We can mention it as angle DAE. Am I right or wrong? This is DAE. In this small triangle ADE. In this small triangle ADE, DAE is one angle, that is 3. Likewise, in the big triangle ABC, this is the big triangle ABC. In this big triangle, angle BAC, this is angle BAC. That is also 3. Am I right or wrong?
Yes, sir.
So for the small triangle ADE and for the big triangle ABC, both have the same angle, that is 3. That is DA. This 3 angle 3 is represented by DAE and as well as BAC. Both are equal. That is step 3. Now, using the 3 steps we have completed just now, what I'm going to conclude is, very important. Using 1, 2, and 3. Using 1, 2, and 3. That is step 1, step 2, and step 3. Using step 1 and step 2 and step 3. What I'm going to conclude here is these 2 triangles, that is triangle ABC, this is the triangle ABC is similar to triangle ADE. Both the triangles are similar to each other. This is the symbol for similar. Do you know the meaning of similar triangles? Yes, sir.
Yes, sir.
So this is the important point. Please put a box. These 2 triangles are similar. How they are similar is by there is a property we have already studied in lower class. That is angle. Or else we can write AAA, triple A, similarity rule. Do you remember this similarity, ma'am?
Yes, sir.
When the 3 angles of 2 triangles are equal means, then the 2 triangles are similar to each other. When the corresponding angles of 2 triangles are equal means, then the 2 triangles are similar to each other. That is why I'm representing here by AAA similarity rule. By AAA similarity rule. That is why, see here, in triangle ABC and ADE, according to the 3 steps, they all have this, both the triangles have, the corresponding angles of both the triangles are equal. See here, in triangle ADE, the angles are angle 3, angle 1, angle 2. Yes or no? These are the 3 angles, right? In triangle ADE. Likewise, in triangle ABC also, angle 3, angle 1, angle 2. Are you able to understand this?
yes,
Yes, sir.
Yes.
Yes, sir.
Now, using these 3 steps, what we are concluding is the 2 triangles are similar to each other by AAA similarity rule. This you have already studied. In the lower class. Now, with the help of this AA similar triangle, there is a property we have studied in our lower class that says if any two triangles are similar, their rays, their corresponding sides are proportional. You know that, you remember that?
Yes, sir.
Yes. So when two triangles are similar, their corresponding sides are proportional. Now, I'm going to roughly draw the triangle because I don't want to scroll again and again. I'll roughly draw here. So no need to draw it again because you have already drawn. There is one time you can draw, that is enough. So this is the triangle, right? This is A, this is B, this is C. This is ABC. Listen now, listen. Now, in this triangle ADE, listen carefully. In this triangle ADE, I will draw it separately. This is triangle ADE. This is ADE. And this is triangle. Again, I'm drawing the bigger triangle. That is ABC. Okay, this is ABC. Are you able to see the difference? This is small triangle ADE. I have drawn it separately. And this is bigger triangle ABC. Now, in these two, because we have just now proved that these two triangles are similar. Just now we have proved that these two triangles are
Similar.
Now, since these two triangles are similar, their corresponding sides are proportional. That is why what I'm going to do is, for AD, what is the corresponding side? For in this triangle AD, for what is the corresponding side of AD in this bigger triangle?
AB.
AB. So first I'm going to write the side AB. I'm going to choose the bigger side, that is AB. Okay, that is AB, or else you can write it as AE also, it is up to me. AB by, what is the corresponding side of AB in the smaller triangle? That is AD. So AB by AD, that is the ratio of the corresponding sides. AB by AD, which is equal to, and what about the side AC? What is the corresponding side of AC in the smaller triangle?
AE.
AE. So that is equal to AC by AE. Are you able to understand this step? This you have to write. After this, you have to write. Please write this and near to this. Okay, this you have to write corresponding sides are proportional. Or else in bracket you can mention. Sorry, I've got to write it in black. This you have to write. That is AB by AD. AB by AD is equal to AC by AE. In bracket you have to write corresponding. When two triangles are similar, we can always say corresponding sides are proportional. For similar triangles, corresponding sides are proportional. We know that property. Please put it in the, write it in the bracket.
Finish, sir.
Finished, Amma? Good. Now, shall I do the next step?
Yes, sir.
Okay, now listen. See here, ma. This, okay, see the diagram, ma. This is A, this is B. This AB can be expressed as AD plus DB. Am I right? Because AD plus DB will give you AB. Are you able to understand this? AD plus DB will give you AB. Yes or no?
Yes, sir.
This is point D. This is A, D, B. So AD plus DB is AB. So what I'm going to do is in the next step, instead of writing AB, see here in the numerator we have AB. I'm going to write this AB in the splitted form. That is AD plus DB. Is it okay, ma, to write AB in this form? There is no problem at all, right? We can write AB as AD plus DB. Anybody have doubt in this step? This is for our convenience we are doing. I'm writing this AB as AD by AD plus DB. Divided by this AD, I'm going to write as it is. This is the next step, which implies, you can put which implies. AD plus DB divided by, what do you have in the denominator? That is AD, which is equal to, similarly, how we can write AC? We can write it in a splitted form, AC.
AE plus EC.
Very good, superb. AE plus EC. So this AE, this is AE plus EC will give you AC. So AC can be expressed as AE plus EC divided by what we have in the denominator, AE. Please write up to this. In a few, sorry, why it is vanishing, I don't know. Okay, in a few steps, we'll get the answer now. Have you all completed up to this step?
Yes, sir.
Okay. Oh, what happened? Okay, it is vanishing. I don't know why it is vanishing. Okay. So please write it correctly, ma. AD plus DB. Please check AD plus DB whole divided by AD, which is equal to AE plus EC. It is going again and again. I don't know why. AE plus EC is divided by AE. Have you all written this? Now, next step is I'm going to this AD is the common denominator. I'm going to split it for both the numerators. That is both the terms in the numerator. That is AD and DB. What we'll get is AD by AD plus DB by AD, DB by AD, which is equal to similarly AE by this AE. Again, this some magic is happening here. Plus AEC by AE. So I have splitted, okay, this LCM. Please write fast. AD by AD plus AB DB by AD is equal to AE by AE plus EC by AE. Are you able to understand this step?
Yes, sir.
Yes.
Oh.
Shall I move on to the next step?
Yes.
Yes. Now listen. Okay, this is AE, ma. Sorry, it is going. See here. This sometimes this vertical lines and horizontal lines are vanishing. Okay. See, this is AD. Okay, now listen. This is plus. It is going again. Now this AD by AD gets cancelled. That becomes 1. Yes or no? AD by AD is 1 plus this is DB. This is DB by AD. This is DB by AD, which is equal to. Sorry, it is AD. It is not AD. It is AB. AD is equal to, again, this AE gets cancelled, it becomes 1 plus we have in the numerator EC. Okay, this is EC divided by AE. Please write fast, ma. Please write fast, don't waste time. All of you write up to this. 1 plus DB by AD is equal to 1 plus EC by AE.
Finish, sir.
Finished, Sama. Now listen, both the sides we have 1. In the left hand side also plus 1 is there, in the right hand side also plus 1 is there. We can cancel this plus 1 and plus 1. Okay, both the sides same term is there, means we can cancel. So what will be remaining? We have DB by AD is equal to EC by AE. EC by AE. Yes or no?
Yes, sir.
Now, the final step. We are in the final step. Taking reciprocal on both the sides. Please write this step, ma. Taking reciprocal on both the steps. Both the sides, sorry. Taking reciprocal. Simply write taking reciprocals. So if we take reciprocal means we have to take it on both the sides. Now dB by AD will become AD by dB. Yes or no? Which is equal to EC by AE will become AC goes to the numerator. So AE will go to the numerator. AE by EC. Now please check. That's it. This is the answer. This is hence proof. This is what they asked us to prove. If a line is drawn parallel to one side of the triangle, then the line divides the other two sides in the same ratio. That is AD by DB is equal to AE by EC. This is what we have to prove. We have proved that. Hence proof. That's it. Okay, here we are only using the basic, I would say, things. When two parallels cut by a transversal, corresponding angles are equal. That we are using here. And similarity, when the corresponding angles of two triangles are equal, then the two triangles are, then the sorry, when two triangles are similar, then the ratio of their corresponding sides are equal. Okay, then their corresponding sides are proportional. We can say the corresponding sides are proportional, or we can say the ratio of their corresponding sides are equal. According to that, we are proceeding this sum, and finally we are proving AD by DB is equal to AE by EC. Okay, this is what they asked us to prove. This is the definition of Thales theorem, or else also called as basic proportionality theorem. Why it is called as basic proportionality theorem means because when a line is drawn parallel to one of the side of a triangle, then the line divides the other two sides in the same ratio. When the line divides the other two sides in the same ratio. When two ratios are equal, we call it as proportional. That is why the another name for Thales theorem is basic proportionality theorem. Have you all completed, ma?
Yes.
Sir.
Yes. Okay, is it easy, this method?
Yes, sir.
Okay, so with this we'll close this class. Okay, we'll finish this class. If you want, in the next class, I will teach this method which is given in your textbook. If you want. So, but one thing you have to do, please practice this method. And still, if you are not feeling comfortable with this method, means I will teach you the another method also that is given in your textbook. But I feel this is the easiest method than the method which is given in your book.
Yes, sir. This is the easiest method.
Yes. Okay, so please practice this method, ma. We'll continue our class tomorrow. Okay.
Okay, sir.
Thank you so much.
Thank you, sir.
Thank you, sir.
Thank you. Thank you so much.